Look up at the night sky and find the constellation Orion, which is hard to miss. Orion the Hunter is one of the most recognizable constellations and is built. A trio of stars points to other celestial wonders. Tonight, let's focus on his shoulder, where a bright reddish star twinkles. That's Betelgeuse, a red supergiant nearing the end of its life. It is much larger and cooler than our sun. If we swapped our sun for Betelgeuse, Earth would be consumed. Its immense size makes Betelgeuse incredibly luminous. In late 2019, Betelgeuse began to dim dramatically. Was this a sign of an impending supernova? Stay tuned. As the holiday season approached in 2019, astronomers noticed something strange about Betelgeuse. The star, normally one of the brightest in the night sky, was noticeably dimmer. At first, this wasn't alarming because Betelgeuse is a variable star and its brightness fluctuates naturally. However, this dimming was different. Betelgeuse continued to fade, reaching an unprecedented low in February 2020. Its brightness had dropped to about 40% of its normal intensity, the faintest it had been in over a century. The dimming was so dramatic that it was visible to the naked eye, and people around the world noticed the change. Betelgeuse became a hot topic of conversation. Astronomers were intrigued and puzzled. What was causing this dramatic dimming? Was it a sign of an impending supernova, a cosmic explosion that would outshine all other stars in the galaxy? Or was something else at play? The great dimming of Betelgeuse had become a celestial mystery, captivating scientists and stargazers worldwide. The race was on to understand what was happening to this giant star. Telescopes around the world and in space were trained on Betelgeuse, collecting data in various wavelengths of light. Theories abounded, each attempting to explain the unusual behavior of this enigmatic star. One of the most exciting possibilities was that Betelgeuse was about to go supernova. Supernovae are among the most powerful and luminous events in the universe, marking the explosive death of massive stars. If Betelgeuse were to explode, it would be visible from Earth even during the day, outshining the full moon for weeks or even months. The prospect of witnessing such a rare and spectacular event was tantalizing. However, other theories proposed less dramatic explanations. Some astronomers suggested that the dimming was caused by large, cool star spots on Betelgeuse's surface, similar to sunspots but on a much grander scale. These star spots could block some of the star's light, making it appear dimmer from Earth. Another theory pointed to the possibility of a dust cloud obscuring our view of Betelgeuse. As massive stars age, they shed material into space, creating clouds of gas and dust. It was plausible that a particularly dense cloud of this material had moved into our line of sight, temporarily dimming the star's light. To solve the mystery of Betelgeuse's dimming, astronomers turned to advanced telescopes both on the ground and in space. These instruments allowed them to observe the star in different wavelengths of light, providing crucial clues about its behavior. One key piece of evidence came from the European Southern Observatory's Very Large Telescope in Chile. Using the sphere instrument on the VLT, astronomers captured the sharpest images ever taken of Betelgeuse's surface. These images revealed a striking change in the star's appearance. Betelgeuse was no longer a uniformly bright disk. Instead, a large dark patch had developed on its southern hemisphere. This patch coincided with the region of the star that had dimmed the most. The observations strongly suggested that the dimming was not caused by a change in Betelgeuse itself, but rather by something blocking our view. Further observations from other telescopes, including the Hubble Space Telescope, confirmed the presence of a large cloud of dust in front of Betelgeuse. This dust cloud, likely formed from material ejected by the star, was absorbing and scattering some of the star's light, making it appear dimmer from Earth. The mystery of the great dimming had been solved. It was caused by a cosmic dust cloud. While the dust cloud explained the dimming, Betelgeuse continued to surprise astronomers. Observations revealed another phenomenon. The star appeared to be rotating much faster than expected. This rapid rotation puzzled scientists as it contradicted our understanding of stellar evolution. Massive stars like Betelgeuse are thought to rotate slowly, especially as they near the end of their lives. As a star expands into a red supergiant, its rotation rate slows down, much like a spinning figure skater extending their arms. However, Betelgeuse's rotation rate was too fast for its size and age. The solution lay in understanding Betelgeuse's atmosphere. Like the Sun, Betelgeuse has a turbulent surface with giant convection cells. These cells create areas of rising and falling gas, appearing as bright and dark patches. Astronomers realized that the rapid rotation was due to these moving convection cells. As the cells moved, they carried bright and dark patches, creating the illusion of rapid rotation. The Great Dimming event may have been temporary, but it served as a reminder that Betelgeuse is living on borrowed time. This red supergiant is nearing the end of its stellar life, and its ultimate fate is inevitable: a spectacular supernova explosion. While the dimming event itself wasn't a sign of an imminent supernova, it provided valuable insights into the processes occurring in the final stages of a massive star's life. The ejection of the dust cloud that caused the dimming is a testament to the increasing instability of Betelgeuse as it runs out of nuclear fuel. Astronomers estimate that Betelgeuse could explode any time within the next 100,000 years. In astronomical terms, that's a relatively short time frame. When it does explode, it will be a truly awe-inspiring event. From Earth, the supernova will be visible even during the day, outshining all other stars in the sky. While a supernova is a destructive event, it is also an essential part of the cosmic cycle of stellar death and rebirth. The explosion will scatter heavy elements forged in the star's core into the surrounding space, elements that will eventually become part of new stars, planets, and even life itself. Betelgeuse, the red supergiant in Orion's shoulder, continues to captivate our imagination. The Great Dimming of 2019 to 2020 provided a unique opportunity to study the complex processes occurring in the late stages of a massive star's life. While the mystery of the dimming has been solved, Betelgeuse remains a source of ongoing fascination and study. Its unpredictable nature, turbulent surface, and impending supernova destiny make Betelgeuse a window into the vast and dynamic universe we inhabit. By studying Betelgeuse and other stars like it, we gain a deeper understanding of stellar evolution, the origins of the elements that make up our world, and the ultimate fate of our own sun. So, the next time you gaze upon the constellation Orion, take a moment to appreciate Betelgeuse. It's a reminder of the beauty, power, and mystery of the cosmos and the incredible journey of stars from birth to death and beyond.